Let us solve some examples, more examples. For this one here, we have a 10-volt source connected to 3 ohm. The resistance here is unknown. Here, this is 1.5 ohm, but the voltage is known. Okay, so how we start solving this problem? As I mentioned before, the first thing is to think about Ohm's law. How do you calculate the voltage or current using Ohm's law? So, for example, in this resistor or the other one, if you know two parameters, voltage, current, resistance. If you know two, you can find the third. Okay, so for example, here I believe that we can apply Ohm's law. Very easy. Why? Because the voltage is 3, the resistance is 1.5. 1.5 ohm. Okay, so now can you calculate the current? Yes, of course. 3 divided by 5 is 2. So this is 2 ampere. So the current is 2 ampere. So just 2 ampere. Yeah, 2 ampere. So you calculate the current 2 ampere. Second, if you look at this one here, okay, the current is 2 ampere because it's the same current. The current is 2 ampere. The resistance is unknown, the voltage is unknown. So if you want use Ohm's law, you can't. Why? Because all what you know is the current. The current is 2 ampere. You don't know the resistance, you don't know the voltage. Okay, so what's the solution here? The solution is to use Kirchhoff voltage law, because you want to calculate the voltage. Okay, you can't calculate the resistance. The resistance, for the resistance, you must use Ohm's law. There's no other option. Okay, so how do you calculate V? V is very simple because you have a 10 volt. This is a 10 volt source, and here you have 3. Then the rest is 7. That's it. So 10 equals 3 plus 7. So V equals 7. 7 volt. Why? Because again, you have the source is 10 volt. One resistor has 3. Then the second one has 7 volt. That's it. Done. So now once you know that the resistance, the voltage is 7 volt. So now you know this voltage is 7 volt. Here it is. So now you can apply Ohm's law. Now you can apply Ohm's law. So the voltage is 7. This voltage is 7. The resistance, the current is 2 ampere. Then 7 divided by 2, this will give you the resistance. So what is the resistance now? 7 divided by 2, which is 3.5 ohm. 3.5 ohm. Okay, 3.5 ohm. So this is how you think about it. If you want to calculate current, again, think about Ohm's law. Calculate voltage, think about Ohm's law. To use Ohm's law, you have to have at least 2. You have to have 2 out of 3. Okay, but if you can't, if you don't have 2 out of 3, so you cannot use Ohm's law. If you want to calculate current, in this case, use Kirchhoff current law. If you want to calculate voltage, use Kirchhoff voltage law. That's it. For resistance, you must use Ohm's law. You don't have another option. Okay, so let us apply this here. This is a 2 ampere source. Okay, since the current is 2 ampere, you don't have to do anything here. 2 ampere, the current is 2 ampere. I is 2 ampere because of the current source. Okay, so now can I apply Ohm's law here for this resistor? The current is 2, right? And the resistance is 5. Okay, good. So now can I calculate Vs? Yes, for sure. Or V5 here, V5. Yes, you can calculate V5. It is 2 times 5. 2 times 5. So it will be 10 volt. 10 volt. That's it. Okay, so V5 is 10 volt. What about V2? Can I calculate V2? Yes. Also, I can calculate V2 using Ohm's law. Why? Because the resistance is 2 and the current is still 2 ampere. Remember, it's the same current. The current does not change. So it's 2 times 2 is 4. So it's 4 volt. 4 volt. Okay. Now, can I calculate Vs? Yes, of course. The voltage across the source is the voltage across the elements. So Vs will be V2 plus V5. V2 and V5. So it will be 4 plus 10. 4 plus 10. So Vs will be these two together. 10 volt and 4 will be 14 volt. 14 volt. That's it. Okay. Second example. Next. I want to calculate voltage and current. I want to calculate I1, I2, V1, V2, and so on. So let's see how can we do that. For example, here, this one here. Can I use Ohm's law? I believe I can, right? Why? Because I know that the voltage is 10. The current is, oh, I don't know the current, but I know the resistance is 0.5, right? The resistance is 0.5. So now can I calculate I1? Yes, I can calculate I1. I1 is 10 divided by 0.5, so it is 20. 20 divided by 0.5, so it is 20 ohm, 20 ampere. So I1 is 20 ampere. Okay. Second, for example, if I want to look at this here. Okay, let's see. How can we do that? Use Ohm's law. Okay. I know only the resistance. Can I calculate voltage or current? No, because the voltage V1 is unknown and I3 is unknown. The voltage and current are unknown. So I can't use Ohm's law here. Okay, what about this one? This one here. So let's see. Can I calculate anything here? Oh my god. This is I2 is unknown, V2 is unknown, R is unknown, so you don't have any knowledge here, so you cannot use Ohm's law here at all. Okay, so what's the solution now? Let's see. Okay, anything is given. Yes. Okay, let's see here. For example, you can use, for example, Kirchhoff's law. Okay, I want to calculate V1 now, for example, because I cannot do anything. I cannot do use Ohm's law. So how can I calculate V1? If you look at this this loop, this one here, okay. Now look at this loop here, this one. Okay, let me use pointer. This is a pointer. Okay, return back. So let's see here. Okay, then you have this 0.5. Looks like this. This is a loop. It has a source here, right? Positive, negative, and this 18 volt. 18 volt. Okay, you have the voltage here is known. The voltage is 10 volt, right? And the voltage here is what? Is V1. V1. Okay, so it is very clear that the 18 volt will be divided between these two elements. 18 volt will be divided between these two elements. Okay, so if this one is 18, this one is 18. Okay, so 18 will be 10 plus 8. 8 volt. So V1 is 8 volt. Make sense? Okay, 18 will be divided between two resistors. This one is 18. This one is 10 and 8. 10 and 8. Now when you apply Kirchhoff voltage law, 18 minus 10 minus 8 will be 0. Okay, or you can say 18 equal 10 plus 8. Then in this case you can calculate the voltage, first voltage, which is V1. V1 equal 8 volt. 8 volt. Okay. Now after you calculate V1, of course you can use Ohm's law right away. Okay, so now let us take this one here. It is 8 volt. The voltage is 8 volt. So what about the current? The current will be 8 divided by 2. That is 4 ampere, right? So it is 4 ampere. So what is this current? It is I3. Okay, let's go to I3. I3 is 4 ampere. So it is 8 divided by the resistance, which is 2. Okay, now let's go to I2, for example, here. How can we calculate? This one is a problem because we don't know I2, we don't know V2, we don't know R. So how we solve it? Let us see. We need to calculate I2. As I said before, I2, to calculate this current, okay, you have to use Ohm's law. If you can't use Ohm's law, use Kirchhoff current law. Kirchhoff current law. So now if we go to this one here, it's very clear that this is a branch. Look like this. Okay, you have a node like this. From this side, you have this current, which is I1. I1 is 20 ampere. We just calculate this one, 20 ampere. This is I1. I1. Right? And then this current is divided between these two branches. What's I3? We just calculated I3. I3 is 4 ampere. So now can I calculate I2? Yes, I can calculate I2. I2 equal what? I2 equal 16. 16 ampere. Why it is 16? Because you have 20 divided between two branches. 20 divided between two branches. So 20 equal 4 plus 16. 4 plus 16. So now let's go back and say, okay, I2 equals 16 ampere. 16 ampere. Okay. Okay, now I still need to calculate R. For R, you must use Ohm's law. So, okay, I2 equals 16. Let me write it here. I2 equals 16. Okay, good. But I still don't know how to calculate R. R is unknown, so I must get V. This is V2. I must get V2. How do I get V2? Okay, use Kirchhoff-Volt's law again. Use of Kirchhoff-Volt's law again. So let us see where it is. Now we can use Kirchhoff-Volt's law again. So let's see. Here it is. This is a voltage source here. Negative. Okay, come on. It's not. Doesn't look nice, but anyway. This is V1. And this is V2. Okay. And this is 4 ampere. 4 volt, sorry. 4 volt. Okay. The voltage here, V1 equal 8 volt. We calculated this before. V1 is 8. Because we said that 18 equal 10 plus 8 volt. Okay. So now, can I say that 4 equal V2 plus V1? Can I say that? The problem, no, I can't. I can't. But let us see here how we calculate this one. Why I did that here, I did not do it here. When I did it here, okay, you see both of them are the same direction. So V1 was in this direction, V2 is in the same direction, and 18 volt was in this direction, from negative to positive, remember. Voltage is in from negative to positive. Okay, so now when I apply Ohm's law, Kirchhoff-Volt's law, 18 volt, if I consider the clockwise as a positive like this. So in this case, 18 is positive because it is in the clockwise direction. 10 is negative because it is opposite to the clockwise, and V1 is opposite, then it will be negative 8 volt. Equals 0. That's right. That's it. So now 18 minus 10 minus 8 is right. It's 0. But in this case, no. This one is in this direction. Okay. And this one is opposite to it. V2 is opposite to it. And this source is in this direction. So now let us see. If I consider the clockwise direction to be positive. So, okay, so let us consider this positive direction like this. This is the positive direction. Okay, so this is clockwise as a positive direction. So now let us see the 8 volt. The 8 volt is clockwise or counterclockwise? This clockwise. V1 is positive. So it is positive 8 volt. Okay. And then V2 is positive or negative? It is negative because it is opposite to the clockwise. Here's the clockwise. And here's V1. It's very clear that they are opposite to each other. So it will be negative V2. Okay. What about the 4 volt? The 4 volt is negative. Why? Because it is opposite to the clockwise. Here's the clockwise. It's going down. This is the clockwise, right? What about V? What is the 4 volt? What about V 4 volt? It is going up. So it's opposite. Then this equal 0. This equal 0. Okay. So now it's very clear that V2 equal what? Equal 4. V2 equal 4. Because if this is 4, 8 minus 4 minus 4 is 0. 8 minus 4 minus 4 is 0. Okay. If you can see also this one is a different way, you can see that as the 4 volt and the V2 are in the same direction. You see they are following the same direction. They are following the same direction like this, in this direction. Both of them. But V1 is opposite to them. So it looks like as if you have V1 as a source and V2 and 4 volt are the loads. So V1 equals these two together. So 8 equal V1 plus 4. You can see this way. If you don't want to do that, you can just apply Kirchhoff voltage law and look at the directions opposite or the same direction of clockwise. So here we calculated V2. So V2 equal what? V2 equal 4 volts. Okay. So now V2 is 4 volt. This added here. So V2 is 4 volt. Can I calculate R now? Yes, of course. You can calculate R because you have 2 out of 3. You know the voltage, you know the current. You can calculate the resistance. The resistance is voltage 4 divided by current 16. 4 divided by 16 is quarter, 0.25 ohm. 0.25 ohm. Okay.